Hi everyone, this is Mohi from the Bar Model Company. Today we're going to look at some more difference problems and get you to actually understand and see why it's so important to use the bar model approach to identify what difference looks like. But then moving on from there, from our last video, then to also think about subtraction and how important the bar model approach can actually support you as teachers to show how subtraction and difference are linked and how that then helps you to solve and understand other problems and strategies that come along with subtraction. So let's jump onto my iPad and see what we can do together here. So got a few things I want to cover. So I've got a list of things that I want to make sure that we cover today's session. So firstly, difference section. So we must have hopefully seen our previous video. And so if you haven't, I'm going to quickly go through it, which just shows you that if we have a kind of bar like this, if we have a bar like this, and we have another bar, we can see that there's a difference between them if one bar is larger or smaller than the other one. And so if I show you another one, duplicate here and add that on there and make it a bit smaller for you and just change the style so we can see it a bit more clearly. Okay, so if we have something along this line, let me just make it a bit darker actually. There we are, that's a bit better. Okay, so we can hopefully just about see that there's a difference between the two bars. This bar, the difference between these two bars are actually just this section here. That's what's making it different, and hence that's the difference. So if you haven't looked at our previous or watched our previous video, then please do look at that and have a kind of good understanding of these two bars and what the difference is and how we would teach the difference and why it's important the language that we're using and the visuals that we're using are connected through the bar model approach. So that's one thing, right? So making sure that we know where the difference section is. That's where the difference is. Now, how does that then help us identify difference between two numbers? Well, we've talked about that as well. If this is, for example, 10, then we're saying this is all 15 as an example, and therefore this must also be 10 because they're the same. And so this extra part here is the 5. That's the difference. The difference between 15 and 10 is 5. And we can literally see the difference there straight away with our example. Now, how does that then support us in questions when it comes to subtraction? Well, subtraction really, in one way, we can think of as the difference between the two numbers. So, for example, when we subtract 15, take away 10 as an example, what we're really saying is what's the difference between 15 and 10? And we can see that difference between 15 and 10, again, highlighted here, is 5. That's the difference between 15 and 10. If we're taking away the 10, this is all gone, then we're left with that difference, that extra part, which is 5. Okay, so hopefully I think most of us are quite confident, I'm sure, with that regard. But then the question arises, a question like, for example, why is it then that when we have something like 25 take away 13, and that's equal to 22 take away 10? Why is that the case? 25 take away 13 is 12, and 22 take away 10 is 12. And so, yeah, 25 take away 13 is equal to 22 take away 10. Why does that work? Why is it that we can say that? And this is the really important part of this video, I feel, right? To show the bar model approach, in essence, in a way that is easy to understand why this works. Why is it the numbers are different, but at the same time, when we subtract 25 take away 13 is 12, and 22 take away 10 is also 12. Why is that the case? I've taken away, let's have a look. I've taken away 3 from 25 to make 22, and I've taken away 3 from 13 to make 10. And so what we're really saying is that when we subtract the same amount from those two numbers, then we still have the same difference. Does that make sense? Why is it that they're the same difference? So let's have a look. Let's have a quick look at this. So we've got a bar here. I want to just delete that bar and try to make it a bit more sustainable. There it is. All right. So we've got a bar here, and let me just change the style again. We'll have something like this, my favorite color because of our branding, right? So here we are. So we've got this lovely green bar, and I'm going to duplicate that and have the same bar here. And so we have the same number in essence, right? Let's say this is 25, take away 13, right? So this is 13, the smaller number. All of this is 13, and we're going to draw 25 out here, which is going to be something like that. Okay, that's going to be 25, and I'm going to need to add an extra part to that so that we can see it being 25. Oops, let me undo that and change the color. Right, so how we're going to do this, let's have a think. Okay, so we've got this extra part here that shows us that 25 is larger than 13, right? But what we're saying is 25 take away 13, the difference between 25 and 13 is here, right? We know that's going to be 12, right? Because 25 take away 13 is 12. Why does 25 take away 13 give us the same answer, right, as 22 take away 10? Why is it that when we subtract 3 from 25 and subtract 3 from 10, why does that work? Well, if we look at this bar, I'm going to show you. If I subtract 3 from 13, right, I'm going to take 1 here, 2, 3. Let's say that's 3, okay? I've subtracted this 3. I'm going to take 3 away from the 25 as well. I've subtracted these 3. What do you see that stays the same? What stays the same is the difference, right? That's why that original video we did last week, or earlier this week maybe, what we showed there was that part is called a difference. Here, we're saying, even if it's, well, 13 take away 3 is 10, and 25 take away 3 now, right up to here now, is going to be 22. Even if we did 22 take away 10 now, the difference still stays the same. That part that we've got as a difference, the orange section, hasn't changed. So even if we take more away, if we take all of this away, the difference doesn't change. All the way up to even 13, if we take 13 away from 13 is 0, right? And if we take 13 away from 25 is 12. And therefore, if we say 12 take away 0, it's still going to be 12, right? The difference stays the same here. And so that's an important part of this video, that pedagogy, that style of teaching, that's showing that different section stayed the same. Even though I'm chunking away, I'm cutting down the number, making it smaller, but the difference stays the same. And so that's an important part of our video today, to make sure that we see that very clearly. And the other part, the final part of this video, the short 10-minute video or so, is going to be where we look at a larger number, right? Let's say we've got something like 1,000, right? Subtract 268. Now, typically, most children would start to look at column subtraction, right? 268, and there's a lot of changes we have to do, right? A lot of regrouping we have to do. So if we're subtracting here, we know we can't subtract 8, 6, or 2 from 0. So typically what happens is that becomes 9. That becomes, is that 9? Is that right? That's not right, is it? That can't be 9. So we can see children make these mistakes, that they get confused when it comes to 1,000 take away any number less than 1,000. And so there are a lot of possibilities of mistakes. So when we reduce that, when we take 1,000 out and we give the 1,000 into the hundreds column, that's 1,000, then we've got 0,000. We don't have any 1,000 left, we've got 1,000 there, right? 1,000, that becomes 9, and that becomes 10. Now we've got 10 tens, we've taken 100 out, 10 tens is 100, and we keep doing that until now we've got 10 ones. We can subtract 8 ones, which is 2, 9 tens, take away 6 tens is 3, 900, take away 200 is 7, and so we have 732. That's one way that children solve this problem. And so thinking about it in this way though, thinking about it in this way that we've just looked at, thinking about the difference between the two numbers, right, is how we can think of 1,000 take away 268. What's the difference between 1,000 and 268? If we think of it in that way, then we can rewrite this as, well, if I take away 1 from both of them, the difference doesn't change. So I can actually do 999 take away 267 as an example, right? And so that 999 take away 267 is going to be a much more efficient, quicker way of finding the answer to 1,000 take away 268. But that requires a lot of confidence from the teacher to be able to produce that lesson where children can see that the difference doesn't change. So actually, I can change the numbers and get the same answer, but then the time I take and the chance of me making mistakes is going to be much smaller if I change it to 999 take away 267. 9 take away 7 is 2, 9 take away 6 is 3, and 900 take away 200 is going to be 700. And so we've got 732, same as before. Can you see the link I'm trying to make? That I've got 1,000. I'm going to write this as my 1,000. I've got 1,000 here, class. And I'm trying to take away 268. That's my 268. And when we do that, we have this. That's our answer. The difference between 1,000 and 268 is what we're looking for. And so what's really important is for our children to actually know that the difference doesn't change if we subtract or add 1 on to the numbers. And so even if it's 1 or any other number actually. And so if we subtract 1 here, that becomes 999. If we subtract 1 here, that becomes 267. And the difference, however, the difference didn't change. The difference is still the same. And so what I could do is 999 take away 267, and that will give me the same answer. And so that's a strategy that we use sometimes in schools, but a strategy that is not really taught very well or taught at all in most cases. It's a pretty impressive strategy which saves a lot of time, and also it reduces the risk of mistakes. And so it's one that I would definitely recommend, but I would only recommend if we are visually seeing that when we subtract, we're really finding the difference between two numbers. And hopefully this video has helped you to understand how we could do that in your classrooms. And we would love to hear from you and any comments that you have about this video and future videos down below. And please do subscribe and let your colleagues know about these videos. So this is our bar model videos. Nearly said it all wrong there. Or blooming bar model. I did say it wrong there. Blooming. They're barming as well, but they're blooming. This is the blooming bar models video series, which is just to kind of elevate the bar model approach, making you think about not just questions, throwing you lots of questions out there, but making us think about the pedagogy behind the bar model approach and making us more confident when we're teaching the bar model approach in our classrooms. So hopefully the bar models will be blooming in your classrooms. If you have any CPD needs for your schools, please do contact us. We'd love to help you, whether you're in England or anywhere else in the world. We support schools all across. We've been all around the world to deliver seminars as well as in-house training. So feel free to contact us for more information. Take care, everyone. Have a lovely holiday. Bye.